Did we learn about square roots last time? Remember how they work? What is that 4 telling us to do? 4 for 1 deal, huh? Yeah. But you know what? Actually, before we do any of the 4 for 1 stuff, is we should reduce the x's and the y's inside. You remember, like, how do you handle x to the 16th? You know, just forget about the root for a minute. Let's just think about that x to the 16th over x to the 8th. What's up with that? What does that do? Yeah, you're going to reduce it, huh? We can just, what do we do with the powers? So the powers will subtract, right? So it's going to actually be x to the 8th. Are you aware of that? So why? Because what is that x to the 16th? 16 x's. You don't have to write this out, but I'll do it once for you just to be super thorough. 4, 5, 6, 7, 8, 9, 10, 11, 12. I don't know if I have room. 13, 14, 15, 16. There we go. That's what x to the 16th means, huh? Just and what does x to the 8th mean? The bottom, well, 8 x's, of course. Right. And so what do? Cancel, 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 a bunch of cancel. And what's left over? 8 x's on the top, huh? Does that make sense? That's why, so really you don't want to do all that. You just want to subtract the powers. But I wanted to give you the reason why power subtraction is correct. Right? Because there's 16 x's on the top, 8 in the bottom, bunch of canceling, and there's 8 left over on the top, aren't there? So we just subtract the powers in that situation. So so this will become x to the 8th. And then what's going to happen with the y's? Same thing, huh? And how many do we have on the bottom? 1. So when we subtract, we're going to get y to the 4th. Good so far? So we just subtract those powers. Now, what do we do from here? Brian, do you want to add something? Yeah, you can do it that way. That's actually the good way to do it. I'll do it the long way, but yeah, if you remember the divide thing, that's even better. So I'll show it longhand for extra clarity. But yeah, really it's going to be dividing, isn't it? By the radicand, exactly right. So so that now we're going to do the root thing. The 4 in the hook tells us it's a 4 for 1 deal at target. So 4 x's in sends 1 x out. Another 4 x's in sends another x out. And 4 y's in sends 1 y out. And what's left over inside the root? Nothing. So it just vanishes, doesn't it, when there's nothing left over. If there was an extra x or y hanging out in there, then we would leave the root. But it's all gone. So what comes out? 1x, another, so 2 x's and a y, better known as x squared y, and we're done. That's the answer to that one. So what Brian was saying is the quick way to do it. Just take that 8 and divide by 4, and take that 4 and divide by 4. That'll make it 2 and 1. You see how that would have been even quicker, right? Because that's what happens. But if I'm at Target and I'm like looking at these candy bars, I'm like, hey, these candy bars are 4 for 1 today. I'm going to grab some of them, and there's 8 candy bars, and they're on sale 4 for 1. If I grab the 8 candy bars, how many am I going to pay for? 2, right? 1 for the first 4, 1 for the next 4. So it's just dividing, isn't it? That's all we're doing. 2 x's come out, 1 y comes in. Good. Other questions on that one? All right. Let's keep moving. On we go. Number 7. So root of 27x cubed. All right. So break down that 27. 3 times 9. 3 times 3. So then we get the root of 333xxx. Good so far? Just broke down that 27 to all the little pieces that make him up. 3 times 3 is 9 times 3 is 27. XXX. Okay. And now we're going to do the ship out. There's nothing in the hook, which really means 2. Understood? You can put it in there if you want. You don't need to. And what's gonna come out? 2 for 1. So 2 3's in, 1 3 out. 2 x's in, 1 x out. So that's 3x on the outside. What's left on the inside? This extra 3 and this extra x are left on the inside, and we're done. It's 3x, square root of 3x. How are we doing? Is that good? Mm-hmm. Questions on that one? Shall we keep right on moving to number 8? So number 8. Square root of 24x squared. Square root of 6x. What's in the hooks for those guys? Nothing, so really 2, yeah. And what about the fact that there's 2 separate square roots? It doesn't matter at all. It doesn't really matter. Just break them all down, and just throw all the stuff in one big square root. It doesn't really matter. There's nothing special about 2 roots. Just do the same old thing, just break it all down and ship it out 2 for 1. Same deal. So I'm going to go 4 times 6, 2, 2, 2, 3, and this one's 2, 3. Yeah, so see all that breakdown from the stuff? So what do we have there? 2, 2, 2, 3, 2, 3. So just put it all in one big root. What is it, 4 2's altogether? 2 3's, and then how many x's altogether? It's like 3 x's, right? 2 and then 1, 3. So there's everything all gathered up. Just making sense so far? So 1, 2, 3, 4 2's, right? 2 3's, and 3 x's. And then we do the ship out, right? The 2 for 1 ship out. Can you grab them and ship them? So 2 2's in, sends 1 2 out. Another 2 2's in, sends another 2 out. 2 3's in, sends a 3 out. 2 x's in, sends an x out. So what do they do when they come out? They multiply just like they were on the inside. You should use your calculator or by hand, either way. Just as 4 times 3 is 12x. What's left in the root? This extra x. There it is. 12x root x is our answer. I made that bigger for no good reason. I don't know why I did that. Just 12x root x, just like that. So with you, that's pretty tricky. Okay, so what are we going to do with this? Yeah, honestly, I'm probably not going to give you anything quite this tricky. I won't on the exam. This is pretty tricky. All right, so what is it? Well, you know what a 2 on anything means, right? If I write, 8 with a 2, what does that mean? 8 times 8 twice. So that means 2 of them, doesn't it? So this 2 here means 2 of all this stuff, doesn't it? So it means root 7, 2 of them. And it means third root of 4, third root of 4. That's a 4 there. Agreed so far? Isn't that what a 2 in the upper right-hand corner of anything means in math, right? 2 of those. Okay. Now what? Well, we can put these 2 together, right, in the same root. And then we can put the other 2 together because they have a different number in the hook. You tracking with me so far? So the 2 7's go together because they're under just a normal root. What's in the hook for the 7's?
2.
Yeah, nothing means 2. And of course there's a 3 in the hook for the 4. So those guys go together and they have to stay separate. Again, I'm not going to give you one where they mix them. I'm not going to give you, this is a little too hard on the test. I'm not going to give you one where they mix them, but we'll do our best here. So now what happens? There's really 2 7's in, 1 7 out, and they're gone, right? Because that one has nothing in the hook, which means 2. 2 for 1 deal. Out comes the 7. So, and what's left in that root? That first root? Nothing. So that first root vanishes, doesn't it? Now, how about the second root? Well, it's third root out. What's the 4? 2 times 2, 2 times 2. Each of those 4's breaks down a little further. Couldn't break down the 7, could I? 7 doesn't break down. 7's already prime. But the 4's break down like that. And then what are we going to ship out? Yeah, because it's a 3 for 1 deal. 3 2's in. 1 2 out, and they're gone. So that 2 that comes out hits the 7 that's already out there. Question?
No.
Makes 14 out there. What's left inside? 2. The 2. So it's 14 cube root of 2. Is that good? Again, I'm not going to give you one like that on the test. That's pretty advanced, mixing them. They won't do that in chemistry. Any other questions on that one? Okay. I'm going to move on if you're good. Number 10. 7 root 35. And 5 root 5. Okay. Example, how about the outside number multiplies the outside number? That's right. 7 times 5, 5 times 7, 35. And then what about the inside numbers? They go together inside. I'm not going to actually times them. Because I need to break them down anyway. Does that make sense? I'm not going to actually go 5 times 35. Is this good so far? So outsiders multiply outsiders. Insiders multiply insiders. So far, so good? See how the insiders go together inside and the outsiders go together outside? What can we do from here? We can break this guy down, right? 5 times 7. That good there. So what do we have? 35 root of 5, 7, 5. That 5 just comes down. That guy goes there, that guy goes there. Good so far. We broke down all the inside like we always do for roots. And how do we know what's coming out? 2 5s in. 1 5 out, huh? 2 for, because there's nothing in the hook there, so it's a 2 for 1 deal. So the 5 comes out, and he's going to multiply that 35. He's going to go times the 35. Was it 150, 175? And what's left inside the root?
7.
Just that 7. And there it is. 175 root 7. So that is definitely fair game for the exam. We'll have one like that for sure. Is that good? Is that making sense? Questions I can answer on that? Is that good? Okay. Let's change gears. Let me do it side by side right here. I think it'll be good. Let's take 8 root 7, and we're going to add 2 root 7. So we're adding 2 square roots. Notice we just changed gears. That's why I wanted it side by side. So number 10 was multiplying a couple of roots. And now number 11, we're adding roots, aren't we? We just changed from multiplying to adding. Okay, so what's the rule for adding a couple of roots? Here's what it is. It's like terms. In other words, it's just like 8x plus 2x. Just pretend those roots are x's and think about what you would do if they were x's, and it's the same thing for roots. So what would you do if you had 8x plus 2x? 8x plus 2x would be 10x. It's not 10x squared. That's when you're multiplying, then it would be 10x squared, right? When you add letters, you just add the numbers in the front. You don't mess with the letters. If you multiply them, that's when you make it x squared. Is that good? So you just add the numbers in the front like that? And so let's do the same thing with the roots. So what's 8 root 7 plus 2 root 7 going to be? 10 root 7. Same exact thing, huh? Just like 8x and 2x is 10x, 8 root 7, 2 root 7 is 10 root 7. So the root 7 is just like an x. Just treat it just like an x. Just add the numbers in the front. Same exact rules as an x. Questions? We good? All right, so to number 12 we go. Minus root of 45 plus 3 square root of 125. So what needs to be done first on that one? You gotta use your calculator, right? Break those roots down and send everything out. So go ahead and do that first. Okay, so break down 5 times 9 is 45. The 9 is 3.
As long as you know what you're doing.
So, and then break down the 125. 5 quarters is $1.25, and 25 is 5 times 5. So break that down, and we get minus the root of 5 times 3 times 3 plus 3. Don't forget that 3 on the outside there. Times the root of 5, 5, 5. Good so far. I just broke them down with my calculator into the pieces or by hand. And now, what's in the hooks here? Nothing, so 2. So 2 for one deal. So 2 3's in, 1 3 out. Oops. 1 3 out, and they're gone. So minus 3 root 5. 2 5's in, 1 5 out. They're gone. So that makes 15 on the outside, leaves 5 on the inside. Good so far. And now, can we add them or subtract them or whatever? Yeah, because they're like roots. Do you know what I mean? Again, it's exactly like letters. So as long as they have the same root, it works. Now, if this was minus 3 root 5 and this was 15 like root 7, that would be unlike roots. Stop right there. That would be just like minus 3x plus 15y or something. You know what I mean? It would be like having different roots are like different letters. You can't combine them. They just stop right there, you know? But if they're the same roots, which these are the same roots, then it's just 15 take away 3 is 12 roots of 5. That's our answer. 12 root of 5. So it's like terms. It's like minus 3x plus 15x. You just add, subtract the numbers in the front. And you keep the root the same.
Was it 2 for 1?
So it's just like minus 3x plus 15x. That would make 12x, wouldn't it? Right? 15 minus 3. That's what this guy and this guy are like. Minus 3 roots of 5 and 15 roots of 5. You subtract those numbers in the front. Questions on? Okay, so this one, we've got the 2 parentheses, and so we know we need to multiply, right? First to both, second to both. Remember how that works? When you're multiplying 2 things with 2 things. First to both, second to both. And as we multiply, the main thing we've got to keep straight is outsiders multiply outsiders, insiders with insiders. Let's do that careful. So this guy goes first to both. So what's going to happen when root 5 multiplies root 5? Are those 2 5s going to multiply each other? Yes, they're both insiders, right? Insiders interact with insiders. So that'll be the root of 25. Next, the root 5 is going to go to the minus 4. By the way, remember the signs. That minus is on that 4, and this plus is on that 9, you know, wherever they may go. So, so again, root 5 times minus 4. Is that 5 and 4 going to multiply each other? No, they live in 2 different worlds, right? The 4's an outsider, the 5's an insider. So minus 4 root 5, like that, and then he's done. Is that good so far? And now it's the 9's turn to go to both, right? First to both, second to both. Now the 9's going to go to both. 9. Now the 9 times the root 5, is the 9 going to multiply the 5 or wait outside? Yeah, because he's an outsider and the 5's an insider. 2 different worlds. And then 9 times 4, negative 4, negative 36, because those are just plain numbers. They're both outsiders. Good so far? Outsiders with outsiders, insiders with insiders. Now, can we do any more? What is the square root of 25? That's just plain old 5, isn't it? Good so far? Now, one more step. 5 and minus 36, those can combine, can't they? They're just plain old normal numbers, no roots or anything. So just 5, take away 36. You can use a calculator if you want to. It's going to be negative 31. Okay, and now what about the 2 in the middle? What about these guys? Yeah, these are like roots. So they can subtract. 9 roots of 5, take away 4 roots of 5 is positive 5 roots of 5, and we're done. See how those 2 in the middle combined? Because they're like roots.
Does it matter?
Yeah.
Does
Alex,
it matter
right?
if you wrote it negative 31 plus 5 root of 5, or could you write the opposite, 5 root of 5 minus 31?
Yeah, you're right, Alex. Good question, and you're exactly right. Both are good. Both are true, right, and good. Hey, could I why don't I subtract minus 31 and 5, get, what's that, minus 26? Why don't I do that? Can I do that? No, because those are unlike. Meaning, you know what it's like? If you're ever looking at a root and you're wondering what the rule is, you should remember that a root is just like an x. So that's minus 31 plus 5x. It's like that. You couldn't combine those, could you? Because they don't both have x's. They're unlike terms. They stay separate. We stop there. Same thing with the roots. Roots are just like x's. It makes them like terms or unlike terms. So we can't go any further. Is that good? Questions I can answer on that? Good. Okay. On to 14 we go. So on 14, 5 cube root of 2 minus 3 cube root of 128. All right, you know what you need to do, right? Take your calculator and break down that 128. Okay, so we break down that 128. Just use your calculator. Divide by 2. You know 2 goes in, huh? Just divide by 2. 2 times 64. And then 64, you might remember 8 times 8. And 2 times 4. And then the 4 is 2 times 2. We good? So we just break it all the way. How many 2's do we end up having? 1, 2, 3, 4, 5. Don't forget him. 6, 7. 7 2's all together when we broke it all the way down like that. So that ends up being 5 cube root of 2 minus 3. Don't forget the 3 on the outside there. Cube root of how many 2's? 7. 2, 3, 4, 5, 6, 7 2's. So I just broke down that 128 with the calculator. And then there's a 3 in the hook. So what does that mean? It's a 3 for 1 deal, isn't it? It's a 3 for 1 deal. So can you ship those out? So let's see it. So we're going to say 3 2's in, 1 2 out, 3 2's in, 1 2 out. And they times with the 3 that's already out there, don't they? Is that good? And so we get 5 cube root of 2 minus, these 3 guys multiply. 3 times 2 is 6, times 2 is 12. Cube root of, what's left in the cube root? Left over 2 there. And now, final step. Are these like? So notice when it comes to adding, subtracting, we ask, are these like roots? Are those like roots? Yeah, same root, huh? So 5 cube roots of 2, take away 12 cube roots of 2. What does that leave us? Negative 7 cube roots of 2. And there we go. All right, try that one. I want you to simplify that. What does it mean when we have a 2 on something? 2 of them, yeah, right? 2 parentheses, and then you're going to do first to both, second to both, right? Like that. So then we take this one to both. So root x, that's root of x squared, plus 11 root x. He's done. He went to both. And then the second one goes to both. Plus 11 root x, plus 11 times 11, 121. How are we doing? So far, so good? And now, what happens with this root of x squared? Yeah, so everybody see, that's just going to be 1 regular x because there's 2 x's in there and it's a 2 for 1 deal, isn't it? Is that okay? 2 x's in, 1 x out, right? Because there's nothing in the hook, which means 2. 2 for 1 deal. 2 x's in, 1 x out. And what's left over inside that root? Nothing at all. So the root vanishes. Plus, and 11 root x and 11 root x? 22 root x, because they're like terms, plus 121. Done. Are we good there? This one will say, rationalize the denominator. And what that means is no root in denominator at the end. So what they want us to do on this problem is they want us to get rid of the root from the denominator. So that's going to be a thing they always do. I don't know if you remember this from your algebra background, that we never leave roots in the bottom. We always have to get rid of them. So how do we get rid of that root from the bottom? What will do that? Does anybody know? Anybody remember from your algebra days? What do we do? Yep, exactly. Good. Multiply the square root of 2 on the top and the bottom. Yeah, you go times square root of 2 over square root of 2. You multiply top and bottom by that square root. What are we trying to do? Trying to get rid of the root from the bottom. We never want to leave roots in the bottom. It's called rationalizing the denominator. So to get rid of that root from the bottom, you multiply top and bottom by square root of 2. Okay, now how do you do it? You just go straight on the top. 1 times root 2 is just root 2. And you go straight on the bottom. Root 2, what's root 2 times root 2? Do you realize it's going to go straight to plane 2? Do you see that? Let me help with that. Root 2 times root 2 is the root of 4, and what's the square root of 4? 2. So we can save time if we'll say, look, 2 square roots, same thing multiplied, will just be one of those plane, won't it? Does that make sense? And of course that's true, because what have we learned about roots? 2 in, 1 out, right? So 2 2's in, 1 2 out. 2 2's in, 1 2 out. So of course, so let me make sure you're making sense out of this. What is the root of 7 times the root of 7? 1 plane 7. Huh. What's the root of 11 times the root of 11? 1 plane 11. What is the root of 19 times the root of 19? 1 plane 19. Now, you making sense? You got it? You're thinking, Mr. Aaron, I got it. I can't be fooled. Really? You ready? You feeling good? Square root of 9 times square root of 9. What's the answer? 3? 9? Uh-oh, see, the insecurity setting in now, huh? Which one is it? 9 or 3? 9? The 9s are rising stronger now. 3s were at first. What? The 9? Yeah, it's 9, not 3. It's 9. Good. Right? Because again, there's 2 9s. So one, I know, but I know a lot of people think, well, yeah, but square root of 9 is 3. Yeah, but he's out at that point. You can't square root him again. He's out. So it's just 9. Right? I've just seen that mistake over the years. So good. So when you have 2 of the same root, it's just one of those plane. Okay. So with that in mind, that's why we do 2 square root of 2's on the bottom, because that makes a plane 2, which is what we wanted, right? No more root on the bottom, and we're done. That's all you have to do on that one. What did we accomplish? We got rid of the root from the bottom. Let's try another one of those. So whenever we have a root on the bottom, notice again, let me recap. Whenever you have a root on the bottom, that's what we started with, you multiply top and bottom by that same thing, and that gets rid of it on the bottom. Because 2 of them on the bottom sends 1 out, doesn't it? Okay, let's try that on number 19. Minus root 3 over root 13. So we multiply by root 13 over root 13, don't we? What happens on the bottom? What's 2 13s in the root on the bottom? 1 plane 13, no longer in a root, right? 2 in, 1 out. What happens on the top? Can these guys multiply each other? Yeah. Insiders with insiders. Don't forget the negative sign. It's just going to be root 39 and we're done. There's nothing else you can do. Hey, why can't we cancel? Doesn't 13 go into 39 3 times? Yeah, but different worlds. One of them's in the root, one of them's out. In jail, out of jail. No interacting. We're done right there. Questions I can answer on that? Okay, now they're going to make it a little more tricky. That's what they always do, huh? As soon as we get something down, they ramp it up. Root 5 over 9 minus root 7. Okay, so we've seen a little bit of the fact that pluses and minuses make everything harder, right? Right? I've done the Costco talk, right? Pluses and minuses glue things together, makes everything in algebra harder. The hard stuff is always where you've got pluses and minuses. So we should expect this is going to be a harder problem because it has subtraction on the bottom. It's just a good thing to, in general, help your mindset as you look at the exam to know which problems are easy and which are hard, you know. The ones with adding, subtracting are the hard ones. The ones that just have multiplying, dividing, those will be the easy ones. So this will be a hard one, which means we've got to do something a little more advanced. Okay, now why? Why can't we just handle it? And first off, what do we want to handle? What's our issue? We don't want the root in the bottom. We're okay with that root 5 on the top. Let me make that a little neater. It doesn't look too neat. We're okay with the root on the top. We have no problem with him. But we can't have a root on the bottom. We cannot leave that root on the bottom. So we got to get rid of it. What's going to get rid of that root from the bottom? Well, watch me try what we just did and see that it doesn't work. If we thought, well, we learned you just multiply top and bottom by root 7. Whatever the root is, you just multiply top and bottom by that. It won't work here. Watch. Don't write this down. This won't work. On the top, it'll be root 35. Okay. On the bottom, what's going to happen on the bottom? Well, what's root 7 times root 7? 7. 9 minus 7? Right, two sevens in a root is 1 7 out. That's 2. What do I mean? That worked beautifully. That was great. And completely wrong. Why? What's wrong?
Because it's a whole package. You can't
Right.
times it. You can't times the top and bottom with just one part of the package. You have to do it by the whole package.
Why not? No, that's not true.
No?
It won't work, but that it's not true to say you can't. You can multiply top and bottom fraction by 1,000,000 if you feel like it. Right? Be logical with me. Don't be rulish. Don't try to do math by rule. You won't get far. Too many rules, too hard. Logic. Think logic. What's true? What's true? What's false? What's true? If I have 7 over 8, right? If I have a fraction and I multiply the top by 1,000,000, let's just do 1,000. I don't want to write all the zeros. By 1,000 and the bottom by 1,000. Is that okay to do? Well, sure. What will it be? 7,000 over 8,000. That's the same fraction, right? This is just a fancy one. You can always multiply a fraction by anything in the world you want to, as long as you do the top and the bottom. You're not going to change it, right? Isn't that logical, reasonable? So let's don't say we can't. Maybe we shouldn't. But we can always multiply top and bottom of a fraction by the same thing, right? That's never going to change it, right?
I think you might misunderstand. I was just saying that you have to.
What I want to know, let me ask this question. I broke a law of math that I hope you see. What law did I break, Brian?
What?
What law did I break?
Oh, you multiply without being in like term. Like that 9 with the root of 7, right?
What do you mean? What did I do?
The bottom, like did you multiply?
What did I do?
The root of this, you multiplied, you didn't distribute all of it.
There it is. I can't just go to this guy. He's got to go to both. That's the mistake I made. I did not distribute, right? So in other words, you got to also go there. You can't just go to one of them. That's a glued package deal. You got to go to both of them, the whole package. Well, is that going to, okay, so what? Is that going to wreck it? Yeah, it will. Because that'll be 9 root 7. The other part was still true. But then, see, we've got a root in the bottom that didn't go away. Make sense? So that's why this doesn't work. Because you would have to distribute to both. All right, so let's get back to it then. So that's not going to work. So now, what will work? What's going to actually work? You multiply. Anybody seen this before? You multiply by the conjugate. Have you heard of that phrase? So these are all things they expect you to know coming in. I'm glad to help you, but I just want to give that warning. Intermediate algebra, lots of conjugate work. If you've never done that, it's going to be super hard because, they assume you know that. So I'm glad to help you with it, though, and Anthony's glad to help you. Conjugate means opposite sign in the middle. Opposite sign in the middle. So that means you take this guy, and you take exactly what he is, and you put the opposite sign in the middle. Like that. That's what'll work. This will work great. So write this down. This will work great. So when do you do that? You use the conjugate when you have a root and a plus or minus in the denominator. That's when you do. When you get the Costco glue package thing going on in the denominator. So when you have a root and a plus or minus glued together, that's when you use the conjugate, use the whole denominator, but opposite sign in the middle. So if the original one had been, let me change the game here. If this had been plus in the middle to begin with, do you know what I would have multiplied top and bottom by? 9 minus root 7. Does that make sense? You just do the opposite sign. Whatever's in the bottom, you just do the opposite. So we had, what did we have? We had minus. We're going to use, therefore, plus. Is that good? Now, this will work. What do I mean work? I mean it'll get rid of the root from the bottom. So here we go. Now this root 5, remember he needs to go to both. That's why I emphasized it's got to distribute. So does the 5 multiply the 9? 5 times 9, 45? No, they're in different worlds, huh? Right? The 9's an outsider. So he's just going to go to the front and the 5 stays in plus, right? Because they're in two different worlds. And then the root 5 times the root 7. Do the 5 and 7 multiply each other? Yeah, because they're both in the same world. Root 35. Okay, that's good. What happens on the bottom now? Well, it's got to go first to both, second to both, huh? So this 9 is going to go to both. So 9 times 9, 81. 9 times root 7 is 9 root 7. He's done. So that 9 went to both. Is that okay so far? That makes sense so far? And then now the minus root 7 is going to have to go to both. So this minus root 7 is going to go to both also. That'll be minus 9 root 7. And now what's going to happen when the minus root 7 hits the plus root 7? We're not adding, subtracting here. We're multiplying. It's minus root 7 times a positive root 7, right? They're multiplying. If they were adding and subtracting, yeah, that'd be 0. But they're timesing. Right? You tracking with me? This is all, right? Don't lose track of what we're doing. This is all multiplication, right? These two guys are multiplying these two guys. So the 9 went to both, and now this guy's going to both. Last step, minus root 7 times plus root 7. Remember what we just practiced on the last screen? In fact, the first one was even root 7, root 7. What is it? Plane 7. Right? So minus root 7 times positive. Negative times positive is negative. Root 7, plane 7. Because it's 2 7s inside. Leads to 1 7 outside, doesn't it? So that's going to be minus plane 7. Is that good? That's why I say I know this is hard if you've never seen it before and you're just being dumped on you all of a sudden. Tons of advanced math steps. All right. So I know this is hard, but if you can give your life to it and come to office hours and Anthony and hours and hours and hours, you could maybe do it if you've never had it before. All right. And now what's going to happen right here? They're going to cancel, aren't they? Because it's just plus 9 root 7 and minus 9 root 7. So they're gone, right? They just zero out. And so what are we left with on the top? 9 root 5 plus root 35 over, what's left up there? 81 minus 7. But we should clean that up. What is that? 9, I shouldn't have, okay, I'm going to have to move it around here. I thought I was done there. So 9 root 5 plus root 35 over 81 minus 7. 81 minus 7, 6, it is 74. And there it is. That was a tough problem. So, okay, so try that one. So here is the situation. You've got a square root in the denominator and a plus or minus sign, huh? Square root. So what do you got to do? Conjugate. Meaning use the entire denominator. You're going to multiply top and bottom by the entire denominator, but opposite sign in the middle. Right? I'm going to jump in with you. So 5 minus 3 root 3 over 5 minus 3 root 3. Is that making sense? We multiply top and bottom by 5 minus 3 root 3, opposite sign in the middle, the exact same as the denominator, but opposite sign in the middle. Okay, and so then this is a big old FOIL on the top and the bottom, isn't it? So this first one goes to both, and then when he's done, the second one goes to both. Okay, now how does it work? How do we actually carry that out? So remember the rule: outsiders with outsiders, insiders with insiders. 3 times 5? 15. Now what about 3 times 3 root 3? 9 root 3, because the 3 multiplied the other 3 on the outside, right? Outsiders with outsiders. He's done. And now this minus root 3 is going to go to both. Be minus 5 root 3, because this 5 is an outsider. He stays outside. And now the last one. Negative times negative, positive 3 root 9, isn't it? Everybody good there? See how the inside 3 multiplied the inside 3? Okay, so now on the bottom, this guy's going to go to both. 5 times 5, 25 minus 15 root 3. He's done. And then this guy's going to go to both. Plus 15 root 3 minus 3 root 3 times 3 root 3, 9 root 9. Getting a little scribbly there. Everybody seeing that? Okay. Now, look what happens on the bottom. These cancel, don't they? Because it's minus 15 root 3 and plus 15 root 3? Okay, so what else happens? On the top we have 15. Now these two right here will combine. Minus 9 root 3 minus 5 root 3 is minus 14 root 3. Is that good? I just combine the numbers in the front. Remember, like roots, you just add the numbers in the front. 9 and 5 is 14. And 3 root 9. What's the square root of 9? Plane 3. Over. What happens on the bottom? 25 minus 9. Again, root 9 here is also 3. Questions on those steps so far? And then, this is 15, minus 14 root 3 plus 9, right? Because 3 times 3 is 9. 25 minus 27. This problem keeps going forever, doesn't it? Bring it over here now. And I'm going to say, okay, 15 and 9, 24, minus 14 root 3 over 25 minus 27, negative 2. It's good so far. And then separate it. So I just put that minus 2 under both of them separately. See how I did there? Put that minus 2 under both of them separately. And then what is this going to be? Negative 12 plus. Do you see how it's going to be minus a minus. It's going to be plus. Oh, I keep writing that. Minus. Yeah, these two minuses are going to make plus. And 2 goes into 14 7 times. 7 root 3. There it is. After all that. That's a hard one. To 23. 512 to the 2/3 power. How about we do it on our calculators? Do you guys have your calculators with you? In the interest of time, 512 to the 2/3 power. Basically, here's how you do it on your calculator. 512, and you got to go to the power. That'd be the up arrow or the x to the y. Right? We're going to use a TI calculator in here, right? So you can do the up arrow or the x to the y button. Either one depends on the calculator. And then put parenthesis 2 divided by 3, hit equals or enter. You got to put parentheses around the 2/3 because you're putting the whole 2/3 up in the power zone. So 512 to the 2/3 power like that. Isn't the answer 64? Yeah. You should get 64. 24, I would handle the same way. It says minus 64 to the 1/3. So just put it into your calculator, but you're going to have to do parentheses around the minus 64 to the power 1/3 up arrow or x to the y, as the case may be, equals, and you should get the answer minus 4 on your calculator. Now remember on the TI calculator, the negative is different than the subtraction. The negative is got parentheses around. That's the negative, and the other, just the straight minus, which is a little bigger, is the subtraction. So you got to use the negative, not the subtraction, or the TI gets super upset. Yeah. So 27 is 125 over 343 to the 2/3. Okay, now how are you going to do an entire fraction? Well, maybe your calculator can handle fractions. So you got to put it in just like it looks. You got to put parentheses around the 125 over 343. I'll show you. You got to put parenthesis 125 divided by 343 to the power or x to the y. And then you got to put parentheses around the 2/3 and equal. That's how you have to do it on a TI. Now some of the other calculators. Oh, and then when you get your answer, you'll get a decimal. You get like 0.5102 blah, 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 blah. And then you have to change it back to, because they want a fraction answer. And the way to change on the TI graphing calculator, the way to change it back is to hit math, the math button, and then enter twice. And it'll change it back to a fraction, and your final answer will be 2549. So now some of the smaller calculators are actually better than the TI. They can handle the fractions directly, and you won't have to change them back. And that'll be super nice. It'll go straight to the 2549ths. Because eventually we'll do that. So these are the steps on the TI 8384. But it's actually better on some of the smaller calculators. Just use your fraction buttons. Okay, so they give us this problem where we're multiplying these x's with powers. I bet you guys remember, like, what do you do with x squared times x cubed? Remember what the rule is there? Let's just do a simple example and then use that knowledge to do the harder one. Yeah, the powers, huh? Remember that? Yeah, that is x to the fifth. So we know we need to add the powers, don't we? So we need to take 4/5, add 1/3, add negative a half, don't we? We've got to add up those powers. Now, you can do it by hand, common denominator, or you could just type them into your calculator and let it do the fractions for you. Either way, it doesn't matter. What's the common denominator going to be? Remember, you multiply all the denominators together? Yeah, 5 times 3 is 15, times 2 is 30. 30 is going to be the common. So by hand, you'd make it 30. So that would multiply top and bottom by 6 on this one. So 24/30ths. Plus top and bottom by, what's that going to be, 10. On this one, be 10/30ths. And top and bottom by 15 on this guy to make it minus 15/30ths. So now you can combine all those. What's that going to be? I think it's 19/30ths. Yeah, 19/30ths. And so the answer then is x to the 19/30ths, right? Because we still have the x. We were just adding up the powers. And your calculator can do that automatically using the fraction buttons. Glad to help you with that. Just come on up when we have a break on that. Okay, so what happens in this situation? We have things with powers and then a power on the outside. Does anybody remember? Like, what if you have like x squared and then you have a 3 out there? Do you add the 2 and the 3 or do you multiply them? Yeah, you multiply. Yeah, you multiply powers outside parentheses with powers inside parentheses. That's right. That's right. So that means I got to take that 1/4. That's a 1/4 there. And I've got to multiply. So what's 1/4 of 28? 7. And 1/4 of 20? 5, and we're done. It just multiplies, and since it's a fraction, it really divides, doesn't it? Those powers.